So some of the faces I recognize. My name is Mike Fawcett. I'm the National Business Development Manager for Panasonic for Professional Imaging. And thanks for coming out today. We're introducing our CX4000, which is the ENG style camera of our CX series. Last year, around February, we introduced the CX350. So this is a handheld camcorder style. This camera is a 422 10-bit. Can record 4K 60 in HEVC or H.265 or 4K 30 in H.264 MOV style format. This camera supports SD card memory. This new camera, ENG style, supports P2 memory as well as SD and micro P2 card formats. We'll go through the presentation. The reason this is a new generation and what we call CX because it's C stands for connectivity and the X just stands for next generation. So one of the emerging things that's coming in the field these days is with 5G coming, 5G networks coming, is connectivity. Now you'll be able to transmit from your camera back to anywhere over network or over wireless. Today in HD, when 5G finally hits the ground running, we'll be able to do it in 4K. So the whole idea is to develop new cameras that will now support the streaming capability or networking connectivity that everyone's been waiting to do seamlessly from the camera without any third-party hardware. So to start by doing the presentation, as I mentioned, back in the old days of film, we went into tape, digital cameras, started getting into non-linear editing systems, solid-state recording, introduction of 4K HDR, 4G LTE connections, cloud connection, which would be through like P2Cast, and now with the new generation of cameras, we're moving into always-on connected. So we'll be able to do live acquisition from camera in the field. So today, has anyone heard of P2Cast from Panasonic? It's basically it's a cloud-based acquisition system. So recently we've switched over to the Amazon Web Services backbone. We were with Microsoft Azure. Last year we switched over to Amazon Web Services because they'll be supporting 5G sooner. But with P2Cast, I can take a camera like this, use a Wi-Fi to my truck, or put a 3G modem on the camera itself. And as I'm shooting, it's uploading a proxy back to your station. You then get the proxy file. You can import that into Premiere or Avid or any of your editing systems. Create an edit list, and then what happens is that edit list gets sent back to the camera. The camera will then start sending the high-res edited content back to the station without the camera operator doing anything. As long as the camera's on and connected, the P2Cast takes care of that whole thing. So we have a server in North America, we have a server in Asia, and we have a server in Europe. So as a P2Cast member, the camera's not actually registered, the operator is registered. So if I have 5 cameras in a pool, and I have 2 operators, you only need 2 licenses, and essentially what you do is you take the SD card for that operator, put it into the camera, it will then change the settings in the camera to support that operator for that particular camera, and then do the upload. Did we lose our audio? No. The other thing we developed is a mobile app. So you can use your iPhone to capture video and then send that into the P2Cast system as well. So you'll be able to arm customers with the mobile app or your talent, so they can actually have the ability to capture P2Cast video anywhere, anytime. That then again gets sent back to the station, is edited, and then put onto air. So if anyone wants to know more information about P2Cast, just let me know. We have done some integration testing with Dejero, because Dejero has expressed interest in being on the P2Cast backbone as well, because we have a lot of customers in the US that are using P2Cast, and some of them have Dejero equipment in the field. Anyway, we'll move on. Stop if you have any questions. So 2 years ago, when we introduced 4K, we introduced 8-bit cameras in the UX180, the UX90, the DVX200. On the HD side, PX5000, which is a full 1080p 422 10-bit camera, the 270 as well. The 800 was a 1080i 422 10-bit, and this PX380 is a 422 10-bit, but 1/3 inch imager instead of a 2/3 inch. Last year, we upgraded the 70 to a 270A, just some software, and the PX5100 was introduced. So the 5000 had no network connectivity or streaming capability. The 5100 added that streaming capability. And then this year in December, we introduced the CX4000. The 350 was February last year, and there's a new 10-bit 4K camera coming in the future. As I mentioned, CX stands for the C stands for connectivity, and I guess creativity, as I can see here. So the other thing we introduced is HDR, being able to create HDR content. Because with the implementation and delivery into the consumer channel, all the HDR TVs, in fact, you probably have a hard time not finding an HDR TV today, this generation. Everyone's asking for HDR content. Who supports HDR right now? Not yet. The good news is that when you are asked to provide HDR with this camera, you can basically turn it on, and it will then support HDR. So you can do it two ways. You can do HLG capture, which is a hybrid log gamma, and by doing that, you're capturing the full dynamic range of the sensor, and then you can actually apply any type of look and post that you want. Or you can actually set the camera up to capture HDR, and it will give you a baked-in HDR look that you can just go straight to air with if you need to. So there's many options in the camera. I'll take you through those going forward. So as I mentioned, the 350 and the 4000. The 350 has a 1-inch sensor. The 4000 introduced a 4/3 inch sensor. So how do we put a 2/3 inch lens on a 4/3 inch sensor? 4/3 inch sensor, almost twice the size. I'll show you in a future slide. We'll skip past this. So we introduced what we call LSSIEL. I wish they'd come up with something easier. But what it did is a large sensor magnifier that sits in front of the sensor and takes that B4 2/3 inch circle and fills the 4/3 inch sensor. So we now can use standard 2/3 inch lenses. If you already own some 2/3 inch lenses and you don't want to go out and change your glass, we can support HD glass as well as 4K glass.
How much of a stop drop do you get?
Probably about a stop, but the camera is already compensated for it.
You're losing a stop on your
Yeah.
glass.
The benefit is that we looked at coming out with all the other manufacturers that are doing a camera of this style are using a 2/3 inch sensor. The problem is you're putting 8 million pixels on a 2/3 inch sensor. So your photo sites are actually quite small. The problem with that is with small photo sites is you have less light gathering capability and lower horizontal resolution. So we went the opposite direction. We started with our studio cameras about 4 years ago, introducing the Lysol technology with 1-inch sensors, and then moved up to a 4/3 sensor on this camera, which gives you almost a double the photo site size, which means you get equal light performance to an HD camera, which with the 4/3 2/3 inch, with a 4K 2/3 inch sensor, you're going to actually have light loss for sure and sensitivity issues. We also wanted to introduce a 4K camera that was familiar. We have Vericam, which is a cinema-style camera. Russell has one. He uses mostly for documentary work. But on the ENG side, people wanted something that they were familiar with. They wanted to have ND filters. They wanted to have color-corrected filters on a dial, as opposed to having to go into a menu and select your color correction. They wanted to have all the bells, buzzers, and whistles that they're used to. Camera operators used to be able to flip between color, wanting to be able to flip NDs on, just by hand, as opposed to having to drive into a menu every time to do it. We also, what we introduced was user buttons. So the user buttons, you can assign functions to those user buttons, and made the menu access available from 3 places. So you have it on the traditional keypad here. We also have a keypad touch screen on the flip-out LCD, and menu control from the front of the camera as well. So 3 different locations to access the menu. Excuse me. So with the large 4.4K sensor, we were able to have larger photo sites, but also be able to produce 2,000 lines of resolution from that sensor. Again, using the B4 mount, you can now use existing lenses in the market, as opposed to having to go out and buy brand new 4K glass. You can use HD glass. You don't have to. The problem with going with larger sensors is that the lenses that, for example, Canon EF style lenses, there's a very limited range of zoom on those lenses. You can't get a 20 times or a 40 times zoom lens affordably that you can do in a 2/3 that you would in an EF. A lot of them don't even exist. There is no 40 times in EF glass. You'd be lucky if you get 10 times in EF glass. So being able to use longer lenses for the type of productions that you do is very, very important. Also, as I mentioned, F11, F10, high sensitivity. So the camera can be switched from normal sensitivity to high sensitivity. So we've done almost similar to what we did with the VariCam. We have 2 amplifiers in the camera, which will, when you switch to high sensitivity, it reads the luminance information at a much lower level using a different amplifier. You switch to normal sensitivity, it uses the standard amplifier to pull that information off the camera. I'm just going to grab some water here. I'm just getting over a... Yeah. Mm-hmm. It gives you about a stop and a half.
Is it similar shot noise? Kind of?
Yeah. Yeah, it's designed to be 800 is the standard ISO in the 350 in this camera, and it would give you the equivalent of about 1600. So twice the sensitivity. So also with HDR or hybrid log gamma, the typical gamma curve on a standard dynamic range camera, and I wish they'd change the terminology because everybody keeps thinking it's a standard definition, but standard dynamic range curve, you're sitting up about 500% is the gamma that you're able to see from shadow to highlight. By using hybrid log gamma, we're actually to pull almost the full 12 stops out of the camera. So in HDR, the HDR standard minimum dynamic range is 12 stops. Any camera that cannot do 12 stops on the sensor is not an HDR camera. So you have to check those specs to make sure that people we're doing high HDR-like or HDR emulation, but typically what they're doing is they're playing with the curve. They're either pulling information away from the shadows and adding it to the highlights, or they're pulling information from the highlights and adding it to the shadows. Basically just moving the curve around. That's not true high dynamic range. So we also have, in the camera, we have different modes. So we have HD mode for standard HD recording, SD for high definition but standard dynamic range, film like 1, 2, and 3, film rec, which gives you about a 600% dynamic range to match to a previous camera that you might already own. For example, if you have a 3100 or an old VariCam 27, if you had a 27, you had a lot of money 15 years ago, because that camera was $75,000. Video rec, and then hybrid log gamma. So with hybrid log gamma, as I mentioned, you set that, you can then output HDR. So you can bake in the HDR, or you can record in HLG, take it into post, and then apply whatever type of look that you want after the fact. A lot of people like that flexibility because it gives them the ability to manipulate the image and the look after the fact. Some people don't have time to do that, so they just want to bake in the look and live with it. Also added with the 350 and the 4000, we've added HEVC, which is essentially H265. So with H265, we actually get twice the efficiency of H264. So if you're recording 100 meg or 400 megabit all intra in H.264, you can record the same quality in H.265 at 200 megabits per second. So you get twice the storage capability from the camera. Also, you could go to twice the frame rate. So at H.264, if you're capable of 30 frames per second, introducing 265, we can go up to 60 frames per second on the same camera. The other thing we introduced as well is P2 Express, which has been available for the Vericam product. This card is a, who's familiar with P2? Everybody. So this is a new card. So this is a P2 Express. So this card is capable of 600 megabits per second, or actually higher than that, 800 megabits per second of recording. So we can record on a 512 card in 100 megabit long GOP 4K, almost 8 hours, just to give you an idea. We also now support SDXC cards in all of our ENG cameras. Who has a Panasonic camera now? Still in use. So it's a full-size ENG Panasonic. Is it a recent one? Okay. So one in the last maybe 5 years, going back to the 600 or the 380, the 800, some of the previous models. We used to only support P2, but the cameras came with a P2 SD card style slot, and we had P2 micro. You can now use SD on those cards with the firmware updated. The big risk with SD is it doesn't have the redundancy that you get from the P2 cards. So if you lose power or somebody pops the card while you're in the middle of recording, you are at risk of losing the entire shoot. Where with P2, you lose only 2 seconds of video. The other thing with P2, for example, is if you record, give it to your assistant, the assistant thinks he loaded it, or he uploaded all the content onto the hard drive, and then you get back and you find out that it's not there, and you've already formatted the card. You contact our service department, they'll be able to actually retrieve that data from the card as long as you didn't start recording again. Even if you formatted the card, as long as you didn't start recording, they'll be able to retrieve that data. So that's always been an advantage of the P2 card format. The other thing is it's a RAID. So it's actually got 4 SD cards in there with an LSI chip. It actually records to all 4 cards in a RAID format. That's why we have that redundancy in the backup capability in the P2 cards. You pay a little bit more, but that's insurance, because it's cheaper to pay a little more for a card than to have to go out and shoot it again. So something to think about. Not that I'm trying to sell you on it, but we do support them all. Anyone familiar with the V classes in SD cards? And this is important now, getting into higher bit rates into 4K. So the SD card organization or association, all the manufacturers that create SD cards are all part of this association, and they meet every year and they talk about the standards and how to move to the next size of card, and they basically create a standard. So the current SDXC standard we're on right now allows you to buy 2 terabytes. So you'll be able to see an SD card in the future that'll actually be 2 terabytes. The scary part is that's a lot of information that on that tiny little card that you could lose in a snowbank. But they introduced the V class. So when the first DSLR started shooting 4K or even in HD, people would just go out, buy a SanDisk card, pop it in. It can do 300 megabits, no problem. Pop it in, start shooting, and then about 20 minutes later, all of a sudden the camera stops recording. And they're like, something wrong with the card. So the SD card organization decided that they needed to come up with a video class, because standard SD card that's not rated with the V is designed to record in bursts. So it'll record for 10 minutes or 20 minutes, and then it'll stop because it has to do a checksum to make sure that it'll look at the amount of bits that are on the card. It'll go back to the camera and say, how many bits did you send me? And the camera says, I sent you 64,000. The card says, I got 64,000. We're good. The problem is, with standard SD cards, that takes a long time. It takes some processing. So the camera has to stop recording in order for that handshake to happen. With video class cards, they design them so that they actually will continuously record. And if you have never seen a V-class card versus an SD card, the SD card has 1 row of pins across the top. The V-class card actually has 2 rows of pins. So it has a right row of pins and a read row of pins. That's why it's able to do that constant checksum without actually having to stop recording. So V30 is the standard HD 100 megabit per second card. You get into the V60, we don't show it here, but V60 allows you to write up to 400 megabits, and the V90 card allows you to go up to 600 megabits per second continuous record. So if you do go out and buy anyone's camera, doesn't have to be ours, but any camera that supports SD, you need to make sure that the cards you're buying are actually V-class for video, not the standard. SanDisk advertised 395 or 400 megabits of recording, but it's not continuous. So it has to have that V series information on the card, or it's not a video class card. So good information to know. So with HEVC, we opted for 420 instead of 422. And the reason is that with an interlace 420, the color information is muted a bit in order to support the 10-bit. But what we found with HEVC, we could support 420 and actually have more color information than interlace 422 in 4K. So visually, a HEVC 4K 420 10-bit recording looks exactly the same as a 4K 422 10-bit recording in H.264. Some sort of magic, but apparently it's visually lossless. There's no color information lost. Yes. In fact, actually, next slide, everyone's supporting HEVC now. But this is what 422 versus 420 look like in standard definition interlace, 1080 interlace, 1080 60p interlace. You can still see there's some differences, but when you actually get into 4K, there's no visual difference between the two, according to the factory. But you're welcome to go out and try it. We haven't heard anyone dispute it yet, and the camera 350 has been out now for almost a year. Yep. So one of the benefits you get from HEVC over H.264 is HEVC can actually be played back using standard QuickTime on a PC with very little CPU load. Where H.264 4K requires a tremendous amount of CPU to be able to process H.264, where decoding it on decoding HEVC can be done on an i7 computer easily. These are just all the everything that we support to date. There are some updates coming, for example, to support the MXF or P2 format. So that will be a firmware update in both the 350 and the 4000 this year. But as you can see, we can do 400 megabit, we can do long GOP, HEVC with different file formats and different system frequencies as well as audio frequency. And then HD, 422 10-bit, 200 megabit, which is most people are used to in MXF, down to long GOP 50. And then MXF, as I mentioned, future update for 1080. This is coming in the spring, and these are supported correctly now. So we can actually do some proxy recording, for example, ABC 12 gigabit, 25, 50, 42. Eventually, we'll be able to do a 6 gigabit proxy as well. Recording devices, so I already talked about this, so we'll pass that one. And in recording times, as I mentioned, for example, in 400 megabit all intra on a 512 gig card, you about 2 hours and 40 minutes. But if you switch that to HD, you're over 4 hours and 16 minutes in ABC intra. You go down to 100 megabit, 10 hours and 40 minutes on a 512, 64 gig card, an hour and 20 minutes. With the P2 Express, It is a thicker card, so old P2 readers won't read it. It's a bit thicker than the previous P2 cards. Well, we introduced the XPD1 probably about 4 years ago, and we now have the XPD3, which is a Thunderbolt. So we can actually read considerably faster than we could have with the even with the XPD1. So 100 megabit Express P2 card, 10 gigabits per second through Thunderbolt back to here, so we can read at 10 gigabits per second. We can do a 500 or 256 gig card in 3.5 minutes download, or 73 times download capability versus our competitors with their product. Oh, Russell, you're looking hard at this one.
Yeah, I know. I was looking at that. What's the max read speed on P2? When does that reach 100 meg?
10 gigabit.
So the actual read on a P2 Express is 10 gigabits per
Yeah.
second.
On this. This can pull it off at 10 gigabits per second. The record speed, or the write speed, is 800 megabits per second. But with the XPD1, it's a much lower. It's a USB 3, so it's a much lower read speed. Where this is a Thunderbolt, so we can actually get up to 10 gigabits. And we found actually when you stack multiple, you can actually increase the read speed even faster because it utilizes the memory in the other units. So if you put a card in one, it'll actually use the memory in the other units.
Well, when you're downloading 4K, like it's on the road.
Yeah. Yeah. When you start getting into RAW, for example, like we have a Codex RAW back for our Vericam. It's 2 terabytes lasts about 20 minutes in that unit. And to offload off of a 2 terabyte hard drive takes almost 45 minutes. So it's a long process. So with connectivity, we have a wireless app that you can have installed on an iPad or an iPhone or Android. That allows you to actually have camera control. So in the case of both the CX350 and the 4000 with a servo lens, I have iris control, I have zoom, focus, everything from that app. So if I'm the only talent, I can actually set up my camera from my phone or from my tablet while I'm ready to start recording. So I can do painting and shading, and I can do all of that through this app. We can do it wirelessly through a wireless dongle that you add to the camera. And we also have the ability, once you've got that connection, you can actually do live streaming. So you could have, for example, network connection to the camera and have a network connection to a tablet if you needed to. Or if you wanted to stream, you could stream over your network. Or put the wireless dongle in, you can then stream directly to YouTube and Facebook or any other RTMP site. So YouTube uses RTMP, and Facebook recently switched to RTMP-S, which is secure. So we had to change all our firmware in order to support RTMP-S, but it does support it, and there's a number of other companies out there that support the RTMP protocol, which is real-time media protocol. So in a camera like this, we can't transmit in 4K, but we can stream from the camera in HD up to 25 megabits per second, so 1080p 60 if you need to. I don't know why you would want to, but you don't need 1080p 60 for the internet. But we're also able to add an activation license to the camera, and we can now stream NDI HX. So NDI is a company called NewTek, who makes TriCaster. Anyone familiar with TriCaster for live production? So we introduced it. NewTek came to us about 5 years ago and said, we're going to develop an NDI protocol. We'd already had cameras built in the field, so we said, well, we can't accept your 80 megabit bit rate in our cameras, but we can do 25 megabits. So they introduced NDI HX. So the HX is a 25 megabit stream versus an 80 megabit stream. The only issue, you have maybe about a 2-frame delay on the NDI HX versus the NDI, which is a half a frame or 1 frame delay. But this allows you now to bring the stream from any one of these cameras back into a TriCaster environment or into the MDI environment. There's probably, I think about 50 different partners that have now supporting NDI and NDI-HX in the field. So, the wireless app, which I talked about already. HEVC coding and streaming. So not only we can support live streaming, but we can also support connecting to a 4G or LTE network. So this camera could be used to go, for example, to P2Cast or connect to here to a truck, which would then upload back to wherever you need it to go. We also support RTP and RTSP formats as well. Stop me if you have any questions. This is an example of a typical NDI infrastructure. So we have a product called HLC100, which is it's an 8-channel NDI-HX SDI production switch. TriCaster. The TriCaster NewTek also has free software as well for doing ISO recording from NDI streams, as well as being able to monitor those streams from a standard PC, plug and pray, as I say, or plug and play. Our pan-tilt zooms support that, and as well the 350 and the 4000. So the main features. As I mentioned, durability, so it's designed based off of Panasonic's E&G cameras philosophy on how to build an E&G camera. So everything that has anything that connects to it has a cover to keep moisture and water out. It is plastic on the outside for weight, but internally it's a magnesium alloy frame. So it's still built to the same standards, but obviously with this thing lugging around on your shoulder, the last thing you want is an 8 or 10 pound camera on your shoulder all day long, not including the lens, right? Yeah, and a 4 pound battery on the back. So being able to make the body lightweight was important. The color LCD, so the side panel LCD is a 720p LCD, 3.5 inch. We also have a monochrome OLED counter display for all of your status information on the camera. Did we lose our battery already? Yep. So up here we have an LED, status LED that will show you, OLED that will show you all kinds of camera information. So here we can see time code information. This is our time code, GPS, if you have GPS turned on the camera, the media status, battery status, and audio levels from this particular one right here. Also got analog. A lot of manufacturers went with new cameras. They started eliminating the analog dials for audio. People still like these. They like to be able to have them set their limits without having to drill down through menus to do it. So we still retain that. We also have it in the smaller cameras as well. So, an important feature. And I said the layout of the camera is very familiar to anyone that's using E&G style cameras today. As I mentioned, does come standard Anton gold mount. This can be field changed. We don't actually sell it, but you can go out and buy a back plate that will support V-mount as well and change it out. As I mentioned, USB device for offloading. So be able to put a hard drive and just offload onto the hard drive from the cards. 5-pin XLR audio out, and we have 4-channel audio in the camera. Also have audio out, as I mentioned, 5-pin, 4-pin shore power, 12 volt, as well as the battery power. There is a unit slot for the microphone, for a mic slot. As I mentioned, camera has GPS. We've got Genlock in, time code in and out, 12G out, 3G out, so 2 SDIs. Gigabit, so that's a gigabit Ethernet terminal as opposed to the 100 megabit. HDMI, which will support UHD and for FHD, as well as DC near the handle for an external light. And then on the front, we've got a 20-pin for the viewfinder, as well as a servo 12 pin for the servo, and then an optional stereo mic in the front. If you wanted to set a mic up on the front, you could utilize the front connector.
One quick note about the audio slot is actually unlocked. So unlike the only slot which actually does have Panasonic Fawcett,
Because we don't have our own, so we don't want to force you to buy a Panasonic one.
Can you record like 4 tracks separately, or
What's that?
4 channel you can record separately, or
It's an audio file in your, so it's a separate file that's in your.
4 channel you record?
4
Yeah.
discrete
Yeah,
tracks.
yeah, 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 yeah. The one on the front would be a stereo, so that would have 2 channels together, but the ones on the back are independent of each other.
So is that, like, can you record 4 separate tracks, or is it 2 tracks separate?
No, 4, just like Vericam. You've got 1 and 2, 3 and 4. It's 2 4-pin, 2 3-pins.
The back is okay. Back is goes separate 2 tracks.
The front
is a 5-pin?
The front is a, where was that slide?
Yeah, reference to
5-pin.
5-pin, okay. Theoretically, you could split.
Yeah. As I mentioned, the depth of field is security from the B4 lens, even though we're using a larger sensor. So you still get that depth of field that you're used to in an E&G, but being a larger sensor, you will get some more of a cinematic depth of field than you would from a standard 2/3 inch on a 2/3 inch sensor. F10, as I mentioned, so all of this stuff we've kind of covered. I can send this presentation to anybody if anyone wants it to take with them. What else have we got here? So third-party support, use a Panasonic viewfinder mic if you want, or anyone's mic. We've got headphone out, on-camera light we support, take sync, jam sync, microphone mixer through the XLR, all kinds of support for third-party products, and these are what Panasonic supplies today. If you were looking for any one of those to go with the camera, style, to give you an idea. Yep. Yes. Yeah. Anywhere in the world? Yeah. Wanted to do CCU support, you would need to put a fiber back on the back of the camera that would then deliver the video signal back to a CCU over fiber. You could then convert that fiber, but if you were doing a simple ROP connection, so an RCP or ROP connected directly to the camera without a CCU, yes, you can do that. Yes. As long as you have a network connection to the camera, yes. You can also use a traditional ROP. We have a traditional ROPs that have Ethernet output on them. So they can be sitting back in your station, connected into your network, and as long as they can have access to that camera, you can actually connect up to 99 cameras from one RCP and do all your shading and painting. It's all based on your network speed, but you're talking about data versus video, so there would be no latency. So yeah, you could essentially have an RCP anywhere in the world, as long as you can see the video coming back from the camera. That would be the issue, is the latency on the video that you're getting back from the camera. So as you're making adjustments, seeing the actual adjustments on screen, that would be the most frustrating if you've got a bad network. So, but if you're using a robust 3G network that has, and you're delivering, let's say 12 megabits per second back from the camera, and your network can support it, and you're getting less than a 1 frame or 2 frame delay as you're making those adjustments, yes, you could see that live. So it's all possible. Now, we all know how reliable the internet is sometimes.